Welcome to physics class. Good morning everyone. My name is Gyasuddin. My dear students, in the previous class we have already learned about de Broglie wavelength and its mathematical expression. So today we are going to discuss about numerical problem based on de Broglie wavelength. Okay. So our first problem is find the de Broglie wavelength of a neutron particle moving with a velocity 2200 meter per second. Mass of the neutron particle is 1.67 into 10 to the power 7 kg. Okay, this is our first numerical problem. According to question, find the de Broglie wavelength of a neutron particle moving with velocity 2200 meter per second. Mass of neutron particle is 1.67 into 10 to the power minus 27 kg. Basically, this is very simple numerical problem. Now we are going to solve this numerical solution. The given information of this question, this is a velocity of the neutron particle. Okay, so B equal 2200 meter per second, and mass of the neutron particle M equal 1.67 into 10 to the power minus 27 kg. Also H means Planck constant 6.62 into 10 to the power minus 34 joule second, and lambda equal what? Okay, we know that for this problem we can use de Broglie wavelength equation. Okay, so we know that lambda equal h by mb. This is known as de Broglie wave equation. In this equation, lambda is called wavelength, h is Planck constant, m mass of the particle, and b velocity of the particle. Okay, so lambda equal, the value of h equal 6.62 into 10 to the power minus 34, mass of the neutron particle 1.67 into 10 to the power minus 27, and the value of b equal 2200. Okay, after solving this part we will get 1.8 into 10 to the power minus 10 meter, and this is equal to 1.8 angstrom. This is equal to. Next problem is an electron is accelerated by applying a potential 1000 volt. What will be the de Broglie wavelength of the electron. Okay, this is our second numerical problem. According to this problem, an electron is accelerated by applying a potential 1000 volt. What will be the de Broglie wavelength of the electron? Okay, this is clear that particle is electron, is not it? This is a particle, electron is particle, okay, and potential is 1000 volt. So the given information of this question, we can write the given information of this question: B equal 1000 volt and mass of electron equal 9.1 into 10 to the power minus 31 kg, and Planck constant H equal 6.62 into 10 to the power minus 34 joule second, and charge of electron equal 1.6 into 10 to the power minus 19 coulomb, and Planck constant H equal 6.62 into 10 to the power minus 34 joule second. What is the value of lambda? Okay, so again we can use de Broglie wavelength equation. We know that lambda equal h by under root of 2m qb. Lambda equal h by under root of 2m qb. Okay, the value of h equal 6.62 into 10 to the power minus 34 under root of 2 into m equal 9.1, mass of electron 9.1 into 10 to the power minus 31 into 1.6 into 10 inverse 19 into B, that means potential difference is equal to 1000 volt. This is 1000. After solving this part, we will get 0.388 into 10 to the power minus 10 meter. So finally we can write 0.388 angstrom. So this is our required wavelength of the electron. For your better understanding, I am going to repeat it once again. An electron is accelerated by the applying a potential 1000 volt. What will be the de Broglie wavelength of the electron? The given information of this question: B equal 1000 volt. This is a potential difference which is applied on a charged particle, okay, and m mass of electron equal 9.1 into 10 inverse 31 kg, and Planck constant 6.62 into 10 to the power minus 34 joule second, and q charge on electron 1.6 into 10 inverse 19 coulomb, and h equal 6.62 into 10 to the minus 34 joule second. Lambda equal what? Okay, we know that lambda equal h by under root of 2 m qb. Generally this is the expression of the de Broglie wavelength in terms of the potential difference, okay. So when the all value substituted in this equation, then we will write lambda equal 0.388 angstrom. The alternative method of this problem, alternatively we can solve this problem. Alternative method, we know that, or we have lambda equal 12.27 under root of b angstrom, okay. So the value of 12.27 and the value of b means b equal 1000, and this is equal to, this is angstrom, okay, and 12.27 and under root of 1000, it means that 10 root 10. Finally we can write 0.388 angstrom. So this is our required wavelength. This is very simple formula we can use for this numerical, okay. Velocity of an electron. Our third problem is velocity of electron electron is equal to half of the velocity of light in vacuum. The rest mass of the electron is 9.1 into 10 to the power minus 31 kg. What is its de Broglie wavelength? What is its de Broglie wavelength? Okay. So this is our third numerical problem. According to this question, velocity of an electron, this is clear that particle is electron is equal to half of velocity of light in vacuum. We know that the speed of the light in vacuum always 3 into 10 to the power 8 meter per second. Okay. The rest mass of electron is 9.1 into 10 to the power minus 31 kg. What is its de Broglie wavelength? Okay. Solution. The given information of this question, we can write mass of electron equal 9.1 into 10 to the power minus 31 kg. Okay. And velocity of electron, this is equal to half of the velocity of light in vacuum. So B equal half into C. C means speed of the light. Okay. And half C, it means that the value of C equal 3 into 10 to the power 8 meter per second. So we can write 1.5 into 10 to the power 8 meter per second. This is the velocity of the electron. And Planck constant H equal 6.62 into 10 to the power minus 34 joule second. Lambda will be what? Okay. Again we can use de Broglie wave equation. We know that lambda equal h by mb, the value of h equal 6.62 into 10 to the power minus 34, and mass of electron equal 9.1 into 10 to the power minus 31, and velocity of the electron, this is equal to half of speed of light. So we can write 1.5 into 10 to the power 8. After solving this part, we will get 0.0419 into 10 to the power minus 10 meter. So this is equal to 0.0419 angstrom, because we know that 10 to the power minus 10 meter equal 1 angstrom. So 0.0419 into 10 to the minus 10 is equal to 0.0419 angstrom. So this is our required wavelength. The concept of this question, suppose this is electron, this particle is electron, and its mass equal 9.1 into 10 to the power minus 31 kg. Okay. And its velocity, this is the half into speed of the light. This is equal to speed half into speed half time of the speed of light. And when the electron moves, the speed is equal to half into speed of light. Then at that time, how much wavelength associated with electron particle? Okay. Suppose this is a de Broglie wave, and this is a particle is electron. This particle is electron. So in this case, how much wavelength? Okay. Now move on fourth numerical problem. Okay, our next problem is, what is the de Broglie wavelength? What is the de Broglie wavelength associated with number A, an electron moving with speed 5.4 into 10 to the power 6 meter per second, and number B, a ball of mass 150 gram traveling with a velocity 30.0 meter per second. This is very simple numerical. Generally this question consists with a two part, first part for electron and second part for ball. Okay. According to this question, what is the de Broglie wavelength of the electron? First part, electron moving with a speed 5.4 into 10 to the power 6 meter per second, and second part, a ball of mass whose mass is 150 gram and traveling with a velocity 30.0 meter per second. Okay. The given information of this question, we can write solution. our first part for electron, say suppose this is our first part for electron, okay. For electron, mass of electron, we know that mass of electron equal 9.1 into 10 to the power minus 31 kg, and velocity, this is equal to 5.4, yes, 5.4 into 10 to the power 6 meter per second, and Planck constant 6.62 into 10 to the power minus 34 joule second. Lambda equal what? It means that we are going to find out wavelength corresponding to electron, okay. So lambda E equal what? So we know that lambda equal h by mb, the value of h equal 6.62 into 10 to the power minus 34, and mass of electron is equal to 9.1 into 10 to the power minus 31, and velocity of the electron equal 5.4 into 10 to the power 6. After solving this part, you will get 1.35 into 10 to the power minus 10 meter, okay. So this is our required wavelength for electron, okay. Now we are going to solve second part of this question. Number B, for ball, mass of ball equal 150 gram, yes, mass of ball equal 150 gram, and we know that gram is not a SI unit of the mass, so it should be converted in SI system. So we can write 150 into 10 to the power minus 3 kg, okay. So this is the mass of the ball, and velocity of the ball equal 30.0 meter per second, and again Planck constant h equal 6.62 into 10 to the power minus 34 joule second, and lambda equal what, okay, lambda equal what. Again we can apply Broglie wave equation. We know that lambda equal h by mb, so the value of h equal 6.62 into 10 to the power minus 34, and the mass of ball 150 into 10 to the power minus 3, and the velocity of the ball equal also 30.0. After solving this part, we will get 1.47 into 10 to the power minus 34 meter. Okay. Now our last numerical problem. Okay, our last numerical problem is an electron of mass 9.1 into 10 to the power minus 31 kg is accelerated by a potential difference 40 volt. What is the gain of kinetic energy? Gain of kinetic energy of the electron. This is our first part, and second part also, what is the wavelength associated with it? What is the wavelength associated with it? Okay. So this is our last numerical problem. According to this question, an electron of mass 9.1 into 10 to the minus 31 kg. As we know that the mass of electron is always equal to 9.1 into 10 to the minus 31 kg. Okay, and this electron is accelerated by the 40 volt potential difference. Okay, so in this case, what is the gain of kinetic energy of the electron? And second part, what is the wavelength associated with it? Okay, the given information of this question, given mass of electron 9.1 into 10 to the power minus 31 kg, and Planck constant H equals 6.62 into 10 to the power minus 34 joule second, and charge Q equal 1.6 into 10 to the power minus 19 coulomb, and kinetic energy, gain of kinetic energy equal what, and lambda equal what. Okay, our first part a little bit concept about kinetic energy of electron. So suppose a electron when accelerated from a certain potential, then we can write kinetic energy of the electron is equal to QB, that means E into B. Okay, so from this concept we can write gain of kinetic energy. This is the first part, our first part. Gain of kinetic energy of electron is equal to Ke equal Q into B, and this QB is equal to, Q means charge of electron, and B, and charge of electron equal Q equal 1.6 into 10 to the power minus 19, and B equal 40 volt. Okay, B equal 40 volt into 40. After solving this part, 6.4 into 10 to the power minus 18 joule. So this is our kinetic energy of the electron. Our second part, we know that lambda equal H by mb. This is de Broglie wave equation. Okay, lambda equal H by mb. The value of H equal 6.62 into 10 to the power minus 34, and mass of electron equal 9.1 into 10 inverse 31 kg. Okay, 9.1 into 10 to the power minus 31, and sorry, lambda equal H by under root of 2 me. Okay, so the value of H equal 6.62 into 10 to the power minus 34, and 2 into mass of electron 9.1 into 10 to the power minus 31 into kinetic energy. This is equal to 6.4 into 10 to the power minus 18. After solving this part, we will get 1.944 into 10 to the power minus 10 meter, and this is equal to 1.944 angstrom, because we know that 1 angstrom equal 10 to the power minus 10 meter. For your better understanding, I am going to repeat it once again. According to this question, an electron of mass 9.1 into 10 to the minus 31 kg, this is our first data, m equal 9.1 into 10 to the minus 31 kg, and H this is equal to Planck constant, H equal 6.62 into 10 inverse 34 joule second, and Q this is equal to charge of electron, so E equal 1.6 into 10 inverse 19 coulomb, and B equal 40 volt, kinetic energy equal what, and lambda equal what. Okay, when a electron say suppose this is a certain potential difference, this is, say suppose this is a B. Okay, when a electron accelerated through A to B side, between A to B, then we can write in this situation electron gain the energy is equal to Q into B. So kinetic energy equal Q into B, and this is equal to E into B. So our this part is gain of kinetic energy, of electron, K equal Q into B, and this is equal to E into B, and the value of E equal 1.6 into 10 inverse 19 coulomb, and B equal 40 volt. After calculation or solving this part, 6.4 into 10 to the minus 18 joule. And second part, actually this is the de Broglie wavelength. This is the expression of de Broglie wavelength in terms of kinetic energy of the particle. So that's why we can write lambda equal H by under root of 2 me, and when the whole value substituted in this equation, then we will get 1.944 angstrom. Thank you.